Welcome. We want to take a look at an example, an application of exponential models. So a population in a certain country has been growing by 3% each year. If the population is currently 35 million people, use a relative growth rate model to determine the population of the country 20 years ago. Essentially, what we want to do is we want time zero to be 20 years ago, and 20 years later, right now, the population is 35 million people. A relative growth rate model says that we're looking for the amount after some time t is equal to the initial amount times e to the rt. The relative growth rate model, or the relative growth rate is r, and the number of years is t here. So what we know, well, we know a couple of things here. The relative growth rate is 3%, 0.03. So that gives us this value here. Of course, time varies. And let's see here, we can find, we have a given value for a of t, and we have a given value for r and t. So we can find the initial amount, right? We know that a of t in this case is p times e to the 0.03 t. And that a of 20, right now, 20 years later, time zero is 20 years ago, this is going to be p times e to the 0.03 times 20. And they're telling us that that is 35 million. So now I have an equation which is actually linear, right? The only thing I don't know here is p. P times a number is equal to a number. That's easy enough. P is going to be equal to, we can write this as 35 divided by 0.03, I'm sorry, e to the 0.03 times 20. Now, using laws of exponents, I could also have written this as 35 times e to the negative 0.03 times 20. So we just need to punch that into our calculator to figure out what that is. So I have e to the power of, let's see here, negative 0.03 times 20. And then I just need to multiply that by the 35 for the current population. This is approximately 19.208. Yep, we'll just leave it at that. That should be sufficient. So the population, 20 years ago, was about 19.21 million. Awesome. Pretty simple, pretty straightforward. And we used, again, the information that we had to create that relative growth rate model.